Hello, everyone, and welcome to the Innovative Technology webinar presented by IWEA Lift Committee. My name is Jane Skitma. I'm the committee chair of the IWEA Lift Committee. Today, our topic is, here, let me get this, there we go. We will be discussing, we have Jim Duncker on, and he will be discussing the USGS and the Next Generation Water Observation System, or NGWOS, in the Illinois River Basin. We're going to have a trivia after this. Had to get canceled due to medical emergency by our hostess. So unfortunately, we're hoping she's okay and everything, but we will not be able to do the trivia today. We'll have someone from H2O for Life join us a little bit later to go over what their program is part of, and we will have a link at the end to give donations if you would feel the want or the need to give the donations. That would be much appreciated. So before we start today too, I wanted to go over, and yeah, there'll be a Q&A after the speaker as well. So I just wanted to let everyone know too, we are part of a Chicago Water Week this week. So if you check out the currentwater.org/Chicago Water Week, there is some really good free webinars if anyone would like to check those out. And before I introduce Jim, I just want to go over some quick Zoom tips. We will be having a Q&A section after, so please put your questions in the Q&A icon at the bottom, and Svetlana will be answering it. She is our vice chair of the IWEA committee. Okay, and then here we go. Here's Jim. Jim Duncker received his bachelor's degree in geology from the University of Colorado in 1982. He began his work for the USGS in 1983 when in graduate school at Northern Illinois. His career with USGS has spanned a wide range of hydrology studies. These projects allowed him to combine stream flow data collection experience with hydraulic studies to develop an understanding of urban hydrology in northeastern Illinois. Some of the projects he has worked on include watershed modeling in suburban Chicago area, monitoring the diversion of Lake Michigan water to the Illinois River Basin for the USACE Lake Michigan Diversion Accounting Program. The LMDA project was helped define the complex hydraulic settings of the Chicago area waterways or CAWS, and contributed to the application of the hydroacoustic flow measurement technology within the USGS. In 2012, he began working on multidisciplinary projects relating to keeping invasive bighead carp out of the Great Lakes. This work has examined links between water quality and the apparent stalling of the bighead carp population front in the lower Des Plaines River. In 2021, he began the basin coordinator for the Illinois River Basin and the lead for the USGS Next Generation Water Observing Systems project. Got it. And I will pass it off to Jim, and now he will share his screen. Oop, I'll do that later. Stop my share and Jim can take over.
Okay, thanks, Jane. Let's see if this works. Can you see my presentation?
Yep, looks good.
Great, and everybody can hear me. Well, thanks.
Yeah.
I really appreciate it, Jane. And you know, I've been in Illinois my whole career, and I'm a hydrologist in the USGS Central Midwest Water Science Center. I work out of the Urbana office, and I am a Chicago kid, born and raised on the South Side. And so I feel like, you know, I learned a lot about my home watershed, you know, and I'm happy to talk about it to IWEA. You know, I know I worked closely with a lot of you over the past, and some new names in the for the presentation. So I look forward to telling you a little bit about it. But let's see if we can get this to advance my screen. It's not advancing my screen, Jane. Oh.
Okay, do you need me to
Yeah.
share? Okay.
Oh, there we.
You got it? Okay.
Okay. So as you can see, just the integrated science activities that are getting underway in this with this project. So the Illinois River Basin is just really diverse, just, capture of pictures, from it extends across 4 states and primarily the state of Illinois, but we extend into Wisconsin, Indiana, and just barely up into Southwest Michigan. But this is just a capture of the diversity of the basin and the diversity of the hydrology of the basin. Next slide.
Oh, that was actually you were able to
okay.
move it.
Okay, thanks.
There you go. Okay.
Okay. So the moniker the name that this USGS project falls under the integrated water science process, but it has actually 4 components and they all have acronyms. And what I want to talk to you today about is we call it next NGWASS, or next generation water observing systems. It's a mouthful, but it's that water droplet observation symbol at the top. And so USGS, we've for over 100 years now, we've been a federal agency that collects water information across the country, and we've developed some standard procedures that we have adhered to, and it's led to consistent data with measurable uncertainty in most cases, and standard operating procedures for how we go about collecting data. And so the change in technology over the last couple decades, it really kind of opened our eyes, and the increasingly advanced computing power and increasingly advanced modeling calls for better data. And so we're really kind of stepping outside our traditional approach to monitoring. And so I'll talk about the different aspects of that, but this NGWASS effort is really to bring that next generation level of monitoring to the basin. And then, so that information feeds interpretive studies, and that's fallen under the Integrated Water Availability Assessments program. And it's a separate program, but we're aligned together and feeding each other information. So that's understanding some of the processes and really, assessing water availability across the country. And that all feeds into leading to build better predictive models. And the modeling world is changing rapidly as well. And so we need to keep pace and to, feed the modelers better data to build better models. And then on the back end is how we deliver that information to the public and to partner agencies. And so we're really revamping databases and access to those databases. So this is, those 4 components. I won't read all of it, but so we started in FY21 back in January with the NGWASS effort. The IWASS effort is spinning up this year in 22. So we just started our fiscal year October 1st. So they're really staggered slightly, but really coming up together. And then we're talking to the modelers and getting direction. And they're in a group called Integrated Water Prediction. And so it's key that we get their feedback and input about what data they need. And so we're looking at data gaps in the basin and trying to address those data gaps, as well as address local stakeholders' needs. And then all of that is leading to the modernization of NGWOS, which is our long-term National Water Information System. And so, the new term is a National Water Dashboard, and it changes the look of things. All that data will be available to the public, but it just changes the look of things, and also more efficient transfer of data for a number of reasons. So the NGWASS and the Integrated Water Science, from our headquarters level, they want to select 10 basins across 10 years. And so the Delaware River Basin was the first, and spun up three years ago, roughly. Last year, they selected the Upper Colorado River Basin. And so back in January, we found out the Illinois River Basin was selected third. And this was really, kind of a competition amongst USGS offices to make the case on what the priority issues are and how we would approach it. And it's of why we should be selected. And so we were really happy back in January to find out that we were selected as the third basin. And so, some of the criteria they were looking at were, how we would go about addressing the issues, intensive monitoring, what kind of assessments and modeling would take place, and how that can be, how transferable it is to other basins like throughout the Midwest. So they were looking for larger river basins, and the criteria were 10 to 20,000 square miles. The Illinois is a little bit bigger than that, but they were willing to take that into account. And then, having that transferability of what we learn in the Illinois to other basins in the Midwest. So, the characteristics of the Illinois lend themselves well to, a relatively large area of the Midwest, so that what we learn here is transferable to those other basins. And then they're looking at, how much engagement from stakeholders, like IWEA and others. And so that's played a role. We're kind of addressing major nationwide issues, but also wanting to be responsive to local stakeholder issues and priorities. So you guys are familiar with this, the Illinois River Basin, it's really two very distinct contrasts between, the extensive urban area of Chicago and the large population and the hydrology of that area, along with the lower basin, where we have, intensive management, agricultural management, primarily corn and beans. And what some of the, those two contrasting land uses, we played that into our proposal as a valuable asset. And so we got our headquarters and the selection committees to agree with us. They were looking at some primary, they call them use cases, primarily nutrients and harmful algal blooms. And so, with the harmful algal blooms, the past few years, they're becoming more frequent and across the nation, but in the Illinois River Basin as well. And so we could address that aspect of the science. And so, and then also Illinois has been recognized as a major source of nutrients to the Gulf hypoxia issue. So those are two of our primary use cases, and we'll be talking about those a little bit more, but so a lot of effort will be, and resources will be targeting those two issues, but at the same time, we have secondary use cases, and we want to try and address a number of issues in the basin. And so I mentioned that, what information we collect during these efforts, it's important that they be transferable to other basins in the Midwest and across the country. And then we're actually, as soon as you start looking at the priority issues, you kind of realize that they cross disciplines in some cases. Water quality issues also have impacts in ecosystem and biology. And so it's a little, for some USGS offices, I sit in a water mission area, and there's an ecosystems area as well. And a lot of the biology and ecosystems work is done out of a different mission area. And so crossing mission areas in the past in USGS was oftentimes difficult to do. And it's less so these days. In the past 10 years, we've really become more integrated. It sounds a little strange, but sometimes different parts of the federal government don't always work and play well together. And so it's kind of unique, and it's been really enjoyable to cross mission areas and share and learn from each other and stuff. So And then, just the outreach and the communication portion of our effort, it's critical to the development of the study plan. And it's just something I feel like we have an existing great relationship in Illinois with our partner agencies and institutions. So the outline for NGWASS, we want to, as we get started, we wanted to catalog the existing data and what models are out there, what networks are out there. And we recognize USGS doesn't do everything. And so, our primary, in the water mission area, our primary efforts have always been stream flow and surface water and groundwater and water quality studies. We haven't, to run these basin scale models, you need time series for meteorological data, evapotranspiration, you need soil moisture. So we're relying on our partner agencies and institutions for access to databases to help build these models with the best available data that's out there. And so that in itself is a little different because the USGS used to really kind of want to go their own route, and not rely on furnished data. And so, but I think in the realities of budgets and in the spirit of pulling to the benefit of the greater good and advancing the science, we want to fill as much of the data gaps as we can and have it be a joint effort as we go forward. So the NGWASS part of it, establishing, we've always kind of established stream gauges, in the lower parts of basins or sub basins, and looking, what we get for data, both, stream flow and water quality is an integrated response from that basin. And so, we started moving up, years ago, we started moving up and working in smaller watersheds, but we want to, NGWASS wants to take the new technology and up into the real low order streams and ditches and really be spatially on the landscape to get a lot more detail. And so that's the kind of information that we can feed modeling groups that is probably most useful. And so it's rather we maintain these long-term gauging stations, which there's a lot of value. We've always placed a lot of emphasis in long-term, long time series records, but here we'll be working short-term and a different suite of instrumentation, and but really to fill spatial gaps in data. And so it's just kind of a different approach, and it's I think it's pretty neat to do, and so that's what we'll be rolling out under the NGWASS moniker stuff. So we're doing as far as data gaps. So there are some low-hanging fruit. We've the collective knowledge of our offices. We recognize where there are data gaps in some cases, and those are relatively easy to address. But we'll be doing a formal gap analysis and using statistical analysis of the existing databases to really look, some of those gaps are not so readily apparent, and we'll be using existing stream flow and water quality models to kind of help us guide our monitoring networks. So all of that will be pulled together and improve, with the ultimate goal of improving predictive modeling of the basin. And then, how we serve that data and that information to the public is kind of one of the end products. So USGS, most are probably familiar with us from our at least the water mission area, from our stream gauges and groundwater monitoring and models. But we can't be everywhere on the landscape. While there are over 11,000 stream gauges in the country, they're only measuring a small number of the total number of stream reaches in the country. And the same goes from a groundwater side. While there are 14 million domestic wells in the country, the USGS is only monitoring about 17,000 wells. So how can we bring this new technology and to spatially even just improve the understanding of what's going on in the watershed? So that density of the monitoring networks has limited the modelers in many ways. And so hopefully we're taking this, the goal is to take this to provide the modelers with the information that they can use best. So back to the NGWASS. So, we found out in January of 21 that we were selected as the third basin. And so, most of my career, I've been, looked at myself as an instrumentation type person. And so, for someone with that kind of interest, NGWASS is almost like a kid in a candy store, because there are just some really cool new tools out there that can collect loads of data that, in the past, we just weren't able, we didn't have access to that kind of information. And so, the approach will be to increase spatial and temporal coverage for a number of critical data parameters, and provide a dense array of sensors at a very select number of sites, and use those state-of-the-art data collection methods. And at the same time, we want to test this new instrumentation against mature technologies and discrete sampling. And so there's an evaluation component that is going along with NGWASS. And, the goal is, improved operational efficiency. And so it comes at it from, to collect these large amounts of data, you have to be able to process it in an efficient manner, and then also to be able to serve it in an efficient manner, so that that modernization of data, databases, data telemetry, quality control, and delivery to the public is the approach that NGWASS is using. So the effort in each basin is a 10-year effort. And so we began in FY21, year 0 to 1 on the x-axis there. And, really throughout the full 10 years, we want to engage with stakeholders. And so I think I'm up to 14 stakeholder meetings. I think probably a few of you have been heard my pitch before, and but we want it to be a two-way line of communication that's just always open, and we'll loop back with updates as we get going. And it's a little more difficult to do at the Zoom and Teams type meetings. I think people don't. If we were all in the room together, the communication would be more engaging in two-way. So it's one of the challenges of that engagement. And so with those stakeholder meetings, we were able to distribute questionnaires that could be filled out afterwards. And so, asking questions about what their priority issues were for the attendees at the stakeholder meetings. And so we've compiled all of those questionnaires, and it helped guide our study plan, the development of our study plan. But, and we're just happy to see that our perceived list of basin priorities are also what are the stakeholders' priorities. And so that's been a process in each of the NGWASS basins to date. So along with that stakeholder engagement, we began exploring, what existing data sets are out there, and compiling at least the links to the metadata for things like soil moisture. And as I mentioned, it's not a parameter that USGS has collected in any standardized approach for our monitoring. but the ag community collects that information, and there's just a wealth of information out there. And I feel really fortunate after talking to basin coordinators in the Delaware and the Colorado, and we just have a very unique collaboration amongst local, state, and federal agencies in Illinois, and a body of work. There's been a lot of work to date in the basin, so it's really I think we're in a good position. And then so we'll do the gap analysis. We're started that. We have a draft science plan put together, and we're waiting for approval of that at our headquarters level. But as we go into year 2, which is 2020, started October 1, this is on the federal year. So we've begun collecting new data, and we started some data collection in 21. We pretty much limited ourselves on purpose because we didn't get started until January, and our emphasis was on stakeholder meetings and procuring data. But we also upgraded a few of our existing stream gauges that were relatively easy to do, where we are already in place. We didn't need permits, and so we were able to upgrade a couple gauging stations in the basin for continuous water quality monitoring and continuous nutrient monitoring. And I'll talk a little bit about that and how that played out this year. And so we're assembling those existing data sets. We have, back on the data collection. So starting October 1, our field crews now, the mountain of equipment that we were able to purchase in FY21 is all being deployed as we speak. And so we're trying to get a lot done before the weather slows things down a bit. But throughout this year, we'll be standing up new instrumentation and getting things out into the watersheds. So you can see, we have timelines for the different tasks, and some of them are in the out years, but we're in year 2, so I won't go too much into it. But the trends analysis and developing those regional and national models and making water availability assessments, these are all and delivering new ways of visualizing data. These are all part of the 10-year program for the Illinois River Basin. So the NGWASS approach is interesting. This is being applied across all the basins. So we got feedback from the National Science Foundation and others on how this different approach should look. And so at the top of this pyramid diagram, we have test beds, and this is where we're testing the new instrumentation. Continuous, for example, continuous nutrient monitoring, the things that the type of instruments that have been in wastewater treatment plants for a while now, they're getting smaller and better and more robust and less power requirements. And so we're putting those up, out at remote gauging stations. And so we've been doing that for a couple of years now. They're labor intensive, and we're comparing different manufacturers, and it's an effort to really, evaluate and work with the manufacturers to really refine instrumentation and make it available out at remote locations. And so we'll be doing a lot of evaluation on a whole range of instruments in the NGWASS program. And then, below that is intensive sub-basin monitoring. And so on the nutrient side, again, I'll give an example, the Illinois nutrient loss reduction program, with working with IEPA, we were able, and MWRD and others, we were able to put out super gauges for most of the major sub-basins in the state over the past few years. But in the Illinois, we had 2, one on the lower Des Plaines, and then one on the Illinois River at Florence, near the mouth of the Illinois. And so we knew what was coming out of Chicago in terms of continuous nutrient monitoring, and we knew what was leaving the basin at Florence. And so with NGWASS, we want to put these super gauges out in more of the sub basins to see, what are the trends in each of the sub-basins? And we know a little bit about that through the Illinois Nutrient Loss Reduction Program, but continuous monitoring in the sub-basins can tell us a lot more. And then basin-wide monitoring and surveys. So, some of the, we call them synoptic surveys. And, one thought that we have is to run a longitudinal survey from the mouth of the river, of the Illinois River, all the way up to into the Des Plaines, into the upper watershed, with a continuous flow through system, water quality monitoring, and get that longitudinal look at what's going on in the river. And doing the same with intensive synoptic surveys of sub-basins gives us a little bit different picture of the information that we see at a point and at a gauging station. And so it really provides useful information to the modelers. And then at the base of the pyramid, we have inventories and remote sensing data. And so this is where the modelers get really excited. So if we can provide a measurement based on satellite measurements that cover a large spatial area, that really tells the modelers. And I'll talk a little bit about how that's being done and some of the new technology. But we're bringing this pyramid approach is kind of our guiding our NGWASS and Illinois River Basin monitoring. So the new technologies I talked about, drone-based equipment is becoming more common and less expensive, but it's state-of-the-art measurements, dense arrays of sensors that provides that increased spatial and temporal data coverage. And we need to know how to get that into a database and out to the public that's easily accessed, And in the lower picture there, you see our EcoMapper, and this is I call it a torpedo. It looks like one. It's an underwater autonomous vehicle. And so we can program it to swim a course. We've had one for a number of years now in Illinois, and up in the head to the right of it is the flow through chamber of water quality parameters. And so the torpedo you can program it to swim a course, and it'll submerge. You can keep it at the surface. You can porpoise it through the water column to get a 3D image of water quality. And every time it surfaces, it orients itself back based on its GPS. And it's a really fascinating piece of equipment. It's expensive. It's new technology. But it really gives us, a 3D look, a different look at data collection, at water quality data. So these are the kind of instrumentation that we can bring to the, that we're bringing to the Illinois River Basin as part of this effort. So you guys are familiar with the basin. It's larger than the parameters that during the basin selection. So we're at almost 29,000 square miles. We cover 4 states, just barely into Southwest Michigan, the upper reaches of the Kankakee Basin, and then Indiana, with most of the basin in Illinois, and then the Fox and Des Plaines up into Southeast Wisconsin. But it covers 44% of the state and 90% of the state's population. And so, one of the things that we really put into the proposal was the contrast between the upper basin and the lower basin, and use that as an asset to why the Illinois River was a good basin to select. So, this is just the major sub-basins, and we're reaching out to stakeholders in each of them, and really trying to help us design data collection. We can't be everywhere at once. We're trying to, sometimes it seems like, but we've had extensive monitoring in both the upper basin and the lower basin in the past. Some of the National Water Quality Assessment, the pilot study in the upper Illinois and then the lower Illinois. So we have this contrast between, a really dense urban area in the upper basin and then, a really fairly uniform, intensively managed agricultural basin in the lower Illinois River. And then I always like this, we have an industrial waterway, and navigation is and commerce is a primary component of the waterway itself. And so in cross section, it tells a lot. We have really two very different hydrologic settings and hydraulic settings. The upper basin is relatively steep. It's hard to convey that to people from Illinois that think of Illinois as flat, but the upper basin bed slope is relatively steep, and you can see that in the size of the height of each of the dams. And then below Starved Rock, so there's very little storage in the basin above Starved Rock, and it conveys the water to the lower basin. And so the lower basin is much gentler slope, a much lower slope. And so with that reduction in slope, you see a reduction in water velocity and deposition of sediment. And the nature of the river, the underlying geology and topography has changed. And the lower river is characterized by large navigational pools with side channel wetlands and backwater areas and 3 national wildlife refuges. So the waterway is managed by the Corps and for a variety of uses, but it moves 30 million tons of commodities. So it's a critical asset to the state of Illinois, and but it plays into the water quality and the priority issues that we see in the basin. So this is just a kind of a brain dump and some of the feedback that we've received from stakeholder meetings, but a lot of it covers a wide range of topics, and not all of them unique to the Illinois River Basin, but very different from what the priority issues are in the Delaware or the priority issues in the upper Colorado. So we're trying to address a lot of these with NGWASS and the integrated water science in the basin. So I mentioned 2 of those primary use cases being nutrients and harmful algal blooms. And this audience knows the Illinois River Basin has been identified as a major contributor to the Gulf hypoxia issue. So the IEPA-led nutrient loss reduction strategy, that work's been ongoing for a number of years now, and so we were part of that, as well as probably a number of you that to really quantify in a logistical way, what are the loads leaving the state of Illinois. And so one of our roles was to deploy 8 super gauges where we're measuring flow, but also a suite of water quality parameters, and really calculate loads from each of the basins leaving the state. And so for the Illinois, that resulted in 2 super gauges. I mentioned the one up in Joliet on the lower Des Plaines, and then one down on the main stem lower river at the Illinois River at Florence. And they initially, with this effort, with this strategy, they targeted some pretty ambitious goals for reduction of nitrogen and phosphorus loads by 2025. And while they haven't necessarily met all of their goals, the trends are in the right direction. And while they are able to show progress towards these, there's some anomalous subbasins that that are not moving in the right direction. And so there's interest in understanding at the sub-basin level what are the contributions. And so one of the things we'll be doing in NGWASS will be funding existing super gauges and upgrading additional super gauges in selected sub-basins. And so we hope to gain that a better spatial understanding of which basins are contributing and what the trends are in nutrient loads. So the super gauge on the lower Des Plaines, told us a lot. We could see the improvements over time. The capital investments in wastewater treatment plants are having the desired results. And so, we can't say the same for some of the non-point sources in some of the ag basins. And so there's a different story going on there as far as the nutrient processing in a sub-basin, things like what are the role of legacy nutrients. And, we have a different setting for a lot of these ag basins that are intensively tiled. And, so there's an alteration to the stream hydrology there, and just what happens between application in a farmer's field and processes that occur in the root zone all the way to the end of the tile to the low order stream and to the main waterway. So those are some of the things that we are looking for better definition and better understanding of those processes. One of the other use cases, our other primary use case is harmful algal blooms. So these are becoming more frequent and commonplace. And I tend to think that the science is relatively young. There's some basic questions, some baseline information on how these, what's generating these blooms. There's an excess of nutrients in the waterway, but sometimes we have nuisance blooms, and what are the triggers that then turn that nuisance bloom into production of toxins and resulting in a harmful algal bloom. And so what NGWASS hopes to do, so in my mind, our response in the past for algal blooms has been sort of reactionary. It's typically reported by the public first, and then we, working with the state and local authorities, they would go out and sample, and then a couple days later get a lab result, and that may or may not have exceeded state thresholds for blooms. And so it's been reactionary, and it's been a point measurement, and in most cases a warning or advisory would be issued to the public. And really, we just had that snapshot, at this time in this location, here's what the status of the algae bloom. And so NGWASS is hoping to bring a lot more information to that event. And so there's new types of technology, new types of cameras that can see things in the water, not at the different wavelengths than what the eye sees, that is useful information to understanding the process of the development of a bloom. And then we can tie a lot of that with water quality sampling and monitoring with in-water sondes, but also tying that to remotely sensed imagery. And so this was an example, I mentioned in 2021, we were trying to really limit our field application, but we put together our HABs team to really address, to catch, we were going to catch that, typical summer HABs, season. And so, we took the equipment we had, we had a gauging station at the Illinois River at Starved Rock. And so, we were planning a dry run for our HABs team. And so at the time we were in a meeting, and the Corps of Engineers reported back to us that, hey, we got a crew at Starved Rock, and there's a bloom currently ongoing. So that scrambled our crew, and it went from being a dry run to hey, this is a real application. And so we were able to work with IEPA and the Corps and get out and sample the bloom, and then over a number of days. And so one of the things that was about that location is it had previous blooms, and we had a gauging station with continuous water quality monitoring, including chlorophyll A. And so we had discrete, crews collect discrete samples and look at the water quality sonde data. And then we were able to reach out to USGS remote sensing group, Jack Eggleston Tyler King, and they were able to schedule satellite imagery for the 10-mile reach at Starved Rock. So those are the pictures that you see along the bottom. The white is our cloud cover, but the Illinois River, you can see the colored lines. It's pretty small, but they are able to correlate what the sensors on the satellite could see with in terms of chlorophyll A and with what was experienced at the sonde. And so the data is preliminary, and it's we're pretty excited about it, but it still needs a lot of work. But to bring that level of monitoring across multiple scales, from discrete sampling to continuous water quality sonde to satellite imagery, is really kind of that whole pyramid that I showed earlier in a snapshot. So this is pretty exciting data that we were able to collect, and we'll be continuing to monitor for HABs both in the Illinois Waterway, the Illinois River, but we're also looking at inland lakes and reservoirs where we might see more frequent bloom conditions. So one of our secondary use cases is emerging contaminants. And so in 2015, we were trying to answer some questions regarding invasive big-headed carp. And so they moved quickly up the Illinois Waterway and become the overwhelming biomass in the lower river. But in the upper waterway, they have been stalled out. The population front is thought of as being stalled out in that reach or near Joliet and on the lower Des Plaines. And so the biologists all recognize this and do intensive monitoring all the way up into the Chicago area waterway system. And so they have a really good handle on where the fish are and where they aren't. And for going on 10 years now, that population front where they can regularly catch adult fish has remained in that lower Des Plaines reach. And so, our hypothesis was that, water quality was having a role, and there's something in the water that this invasive species doesn't like. And that was sort of naive of us to think that there might be one sort of smoking gun. And so we did some very intensive sampling, 4 events across the year, from spring to high flow to low summer flows to even lower autumn flows. And we did a Lagrangian sampling where we were trying to time our samples from upriver to downriver based on trying to capture that same packet of water. And based on the velocities, it would spread out our sampling times. And so the results were pretty interesting. Water quality samples were analyzed for over 639 constituents, 280 of which were detected at least once. This data was all published back in 2017. And, even state-of-the-art wastewater treatment facilities don't remove, a lot of what you see advertised on TV, but, they fall into a group labeled as anthropogenic bioactive chemicals, but include pesticides, pharmaceuticals, hormones, and VOCs. And so we published all of this data. Some follow-up data has been done working with biologists. A publication came out a couple of weeks ago kind of explaining, they were able to sample, as a follow-up to this work, they were able to sample livers of invasive carp, collected from downriver at Havana, all the way up different locations. And as you get progressively closer to that leading edge, the overall health of the fish is diminished. Their livers are, there's enzymes in the livers that we're going overboard and fighting off infections and things like that, that livers do. So they could quantitatively assess the health of the fish through liver enzymes, and really are helping explain some of the story on why this population front has been stalled out. So with NGWASS, we're thinking that this is a really useful baseline of data, not only for invasive carp, but it tells us, it gives us the baseline setting of water quality from which we can then make assessments of, why are we seeing more frequent blooms, and are there things now that have changed and in the baseline water quality, and how has this over time affected the algal community? And so those are some of the questions that we're asking. And so we are not duplicating the same effort, but continuing kind of a subset of the same sort of sampling for emerging contaminants at a select number of locations. And as I mentioned, we're working across emission areas, and so it's been, one of the real pleasures of my career is we're not working in silos, and we're able to bring this water data and water quality data to biologists and really kind of make those cross discipline connections, and that's really where the science needs. We're not things happen across scientific disciplines, and so that's been some enjoyable work, and we'll continue some of that collaborations with NGWASS as we go forward. So one aspect of it, of the analysis of harmful algal blooms. So I sit in the water mission area in the water resources office in Illinois, and our office does not have the expertise on algae and invasive carp, but we are able to reach out to USGS partners in ecosystems based out of La Crosse and Columbia, Missouri, and bring in the biologists to really help us explain some of the data and information that we're getting. So, a priority issue that doesn't seem to go away is urban flooding. And so the DNR released a report a couple of years ago, and quantifying damages from urban flooding. And so much of this is non-riverine flooding, so away from the floodplain, and locally heavy storms, the frequency seems to be getting increasing occurrences. And so are there things that we can do with new technology, smart sensors and new means of telemetry and cloud-based data storage? That sort of changes, that instrumentation, that next generation instrumentation changes the capabilities of water alert systems. So we're trying to bring that level of monitoring. So we're working with the Corps Silver Jackets group and MWRD to bring this level of monitoring to an urban setting. And we'll be rolling that out later this year, but we're still in the planning stages, but it's addressing one of the stakeholder, a primary stakeholder issue in our basin. So as I mentioned, it's been a busy year. We've held a number of stakeholder meetings. Our team is working to identify data gaps. We've been able to bring in people who do statistical gap analysis nationwide for USGS and some of the tools they have to really help guide our data collection efforts. And we started developing a study plan last spring. It's currently in review by my bosses at headquarters, but that'll be available to the public soon. And then we bought a lot of equipment this year, or in FY21. I have an office full of it if I ever get back to the office. But it's starting to move out. And so our field teams, our field crews and technicians, October 1 was their start date. And so those field installations are starting to occur, and we'll go through FY22. And then, we have efforts underway to partner with the other agencies and institutions to access the time series data we need for to provide to the modeling group. And then this is my last slide, stakeholder priority issues. As I mentioned, it's hard to hold stakeholder meetings through Zoom or Teams. and get communications back and forth, you know. And so if we are all in a room together, it's much easier. People are you know, the line of the communication travels two ways. I think it's one of the things I've noticed, but we plan to continue this these stakeholder meetings and periodic updates of how NGWASS is doing. And if there's as I mentioned, there's opportunities for feedback, and if there's locations that are important to stakeholders, we can try to accommodate the deployment of a lot of this instrumentation. So I'm available for questions, and I think that's my last slide. Yep.
Thank you, Jim. I will put this up real quick for anyone that's interested in the, hang on, I'm just sharing my screen here. Oh, it's down there. I'm trying to talk here. Sorry, I'm trying to multitask at the same time. The credit course ID number, if anyone's interested in getting the certificates. So that is there. And now we will have the Q&A, and I will pass it off to Svetlana. I'm also going to put a link for donations if anyone wants to do that. And we'll hear from H2O for Life right after this too, after the Q&A. Okay, take it away, Svetlana.
Thank you all so much who were able to attend today's presentation. Thank you so much, Jim, for this fascinating presentation and really impressive amount of work that you're doing. I have tons of questions that I'd like to ask, but we do have also a question in our Q&A. I do want to say that we didn't have as many participants today as we were hoping to have, but we did record the presentation, and that will hopefully be available, because I think this is such a fascinating topic and such really, you know, great work that a lot of people, I'm sure, would be interested in hearing about. So the question that we have is from Frederick, and is what biological data is being gathered? Data that relates to the health and diversity of the fish and microinvertebrate communities.
Yeah, that's a good question. So as I mentioned, we're working across mission areas within USGS. Like algal community data and paraphyton data, and you know, those are things that a typical water science center may not have that expertise. So you know, we're able to tie into our ecosystem folks at the Upper Mississippi Environmental Science Center and the up in La Crosse, and then the invasive carp group out of USGS Columbia Environmental Research Center in Columbia, Missouri. So we are partnered with the Illinois DNR and the Illinois Natural History Survey on invasive carp issues. And so there's really been, you know, the intensive effort to study the invasive carp, you know, has really advanced what we know. You know, we know more about invasive carp in the Illinois Waterway, and really pushed along a lot of the native study of native species as well. So, you know, compared to other locations. And so that science has advanced pretty far. We know, you know, I think back 10 years, what we knew about the fish community data in the Illinois, and you know, prior to the, you know, to the carp issue. And so on macroinvertebrates, you know, we kind of defer to folks with those specialties in the Illinois Natural History Survey and the DNR and some of the UMass folks. So there is some new data being collected that kind of aligns with what they're doing. Probably not directly within the NGWASS effort.
We have another question from Kuldeep Kumar. He's asking how NGWASS will be helpful in attributing enhanced nutrients in waterways due to climate change.
Yeah, that's another good question. So the overarching the overarching umbrella that NGWASS and IWASS falls under is the interpretive modeling. And so the modelers, you know, forefront on their task is to address how climate change will affect you know, things like nutrients and harmful algal blooms in the Illinois Waterway and in the Illinois River Basin. So so the data, you know, for these advanced models is, you know, the better, the more spatially and temporally density of, you know, the better density of monitoring, you know, will contribute to the models, which will help address, you know, questions like what effect they'll have on climate change.
Yeah, that's a really interesting question. I agree.
Yeah.
Well, I guess because we're at time, I'll save my questions for later. I'll just email you them.
Oh, that's great. Yeah.
I have a whole 2 pages of questions here. I wanted to, I know that we invited Patty Hall from H2O for Life to talk about their organization, and just, you know, didn't want to delay it for too long and give her opportunity to speak. Thank you.
Hi, I am here. Can you hear me?
Yes.
Okay, I'm in my car, so you caught me in my car because I had to get in and start moving to another meeting. But thank you so much for inviting me to be here today. I've listened to the whole presentation and I learned a lot. A lot of it's way over my head, but it was very interesting and strikes up some great points. And for those of you that don't know what H2O for Life is, we are an organization that engages youth across the US to learn about the global water crisis and to figure out what they can do personally to conserve and protect our water resources for the future. And then the action piece is that they raise funds to support implementation of water sanitation and hygiene education for schools around the world. So to date, we've engaged 1 million kids across the US to do this work. They have provided water for over 1,100 schools worldwide, which has made a huge impact. But I think the bigger impact is we're raising kids to understand that water is a resource we really all need to stand up for and protect. And our hope is to get these water kids going and making a big difference in the future. We also have a new program called Water Guardians. It's aimed at 5th through 8th graders. It takes them on a journey down the Mississippi River. And through that journey, they talk about pollution, things that happen because of development, things that should be happening, and how they can be leaders of change. So if you have any questions for me, I would be happy to answer them. But thank you so much for inviting me. We greatly appreciate your support.
Sure. Patty, I would just add that, you know, there is an outreach component to the NGWASS that right now we're talking with Paul Ritter, is an award-winning high school science teacher in Pontiac, Illinois. And he's, you know, he has more energy than any one person should have. And he just is really engaging with his students. And so they're in the Vermilion sub-watershed to the Illinois. And so we're working with them to help them, you know, assign them some homework and from, you know, tasks, but then also to engage them to get in the field and collect some of the data, you know, and it's, you know, working with the next generation of scientists, really. So it's pretty cool.
Well, it's so important. And I was a teacher when this organization was founded. And I brought the project to my school because I really wanted to help a community in Africa that I knew of. But when I went and visited the project and came back with photos and showed kids what their actions had done, they truly believed they can change the world. Yeah. And they can. And we need them to be changing the world today. We can't wait for them to get to be 50 years old. They need to be doing it now. So our program really engages kids to do local actions and pair them with global actions.
It's pretty amazing to see the response. You know, the public, I think they hear it from our generation, and it tends to be, you know, it flows past them without sinking in. But if they hear it from a teenager who's really passionate about the subject, oh boy, it just sinks home, you know, in a whole different way. And so, you know, recognizing that, you know, has been really cool. And so, you know, we're excited about the outreach opportunities. Sure.
Well, any connections that you have, we'd love to reach out to more schools because we feel we've got really great educational tools for teachers to introduce the topic, and then a lot of different action pieces that kids can do as well.
Yeah.
It's great to hear, Patty. Thank you so much for making time to be here.
Oh, thank you. It's my pleasure.
I actually work also for a nonprofit organization, and we launched a program for high school students related to water because we realized there was no water-related science curriculum at present, and we live right by the lake, right? And we have Chicago River, so it felt like really huge gap.
Right.
So I'd like to also reach out and
sure, please do.
You're doing.
Yeah,
So,
and I think that a good action piece changes kids for years. When they really have participated in taking action that really has measurable impact, they know they can make a difference and they can be change makers, and the leadership skills that come out of it are just amazing for young people.
Yes, I agree. Amazing, and there's so much hope in these young people to really change things, because we really do need change.
Yes, we do. So thank you for sharing your information too. It was very interesting.
Okay, thank you so much, Patty.
Thank you.
Jane, I just wanted to check with you. I know we planned for another half an hour before trivia, but if people who just late were not aware, we actually had to cancel our trivia today because our host was not available, had an emergency situation. So if would this be a good time to stop, or should we just?
If Jim wants to, if we have more questions, you can do a couple more questions. I'm here. I'm available. I know it's unfortunate we had to cancel the trivia, but I did put the link for the donation, and we'll keep that link up for a couple more days too, just to see if anyone else trickles in too. But yeah, if you take it away, if you want to do some more quick questions, if Jim's okay with that.
Well, I guess I just want to ask one question that relates to this whole huge effort that your team is undertaking. It's just mind-boggling, just to think of starting with data collection and sampling, and then a huge piece of it is data validation, and then you have data analysis, and then integrating all the data and really trying to communicate, then interpret it for the public to see how it is relevant to these different stakeholders and the public. That's just an enormous amount of work. And so I just wanted to ask how so you were talking, Jim, about engaging stakeholders, and I just wanted to see if you can talk a little bit more about who you're engaging and what they're doing to help you to advance your work, and maybe also what help you're looking for.
Yeah. So as you mentioned, I think I'm 13 or 14 stakeholder meetings. We've had large ones. My first stakeholder meeting was with the Upper Mississippi River Basin Association. And so there's been people who've heard my pitch several times, the Illinois State Water Plan Task Force, the U.S. Army Corps of Engineer offices, MWRD, and IEPA, the Illinois Nutrient Council. So we've talked about to the Kankakee and Yellow River Basin Commission. We've talked with Wisconsin DNR. So we're trying to check all of the boxes. If people, on the small side, we talked with the watershed groups, the Flint Creek and Spring Creek watershed groups in Lake County, and the Northwest Planning Alliance, I think it is. So water supply and municipalities along the Fox River. And so we're really reaching out to whoever we can talk to engage. And so my contact information was there in the slide, and if people would like to hear more from us, we're you know, and we really like to have it be a two-way line of communication. So that's been one of my larger tasks this in FY21 to date. So
excellent.
and it's nice, you know, usually USGS programs, we're looking for financial partners, you know, and it's nice. It's really nice with this project is it's funded through Congress, and we don't have to ask for funding, you know, from partners. And that's you know, we you know, the challenge of trying to be everywhere to everyone is an issue, but we're doing our best to really to spread the wealth of and to address the monitoring issues, both from a local stakeholder all the way up to the national modeling group.
That's wonderful. And I know that my organization, Current, we would really like to be involved and be helpful in your work. So I will be getting in touch and to see how we can help, especially reaching out to maybe community partners and working with the public.
Yeah.
That would be something we'd love to do. So
yeah.
Thank you so much again, Jim. We don't have any more questions in Q&A, and probably will be a good time to stop. It was again a really great presentation, and really appreciate your time and effort.
Yes, thanks for inviting me. I really enjoyed talking about it.
Yeah, you can be a participant for trivia next time too.
Okay.
Cool.
Thank you to Fuldy also to putting it together, to inviting the speaker, and that was really a great choice.
Yeah.
Thank you, Fuldy.
Thank you.
Thank
Thank you,
you.
everyone. Thanks, Jim.
Bye now.
Bye.
Bye.